All right, good morning and welcome to Tuesday morning, September 8th, M100. I unplugged my other monitor. I don't know if that was part of the problem. It's a new setup that I was trying, and so everything's going to be on this screen right here. So I want to share my screen here and show you in Canvas something that I just uploaded in announcements. So let me get over to that. So everything's going to be right here. So it's going to be a little more awkward. I worked really hard to try and smooth it all out, but I'll have to do some more experimenting outside of class time. So let me go ahead and share this. All right. So Emily Soika, thumbs up. Can you see the Canvas page? Thank you very much. You're one of the like 3 people that showed up in my margin here. Okay, so I just uploaded a practice test. Okay, this practice test is exactly that. It's a very short little test that I want you guys to print out and, you know, do the problems on the paper. Then I want you to send it back to me, and I'll talk about how to do that in a little bit. So just open up the announcement that I posted this morning. Down here in the corner or underneath, you'll see practice test for extra credit. And it is extra credit, so if you don't do it, it's not going to hurt you. But this is a practice that will give you a feel for how all of our quizzes and tests are going to be done, with the exception of the midterm and the final. I'm still trying to work out how you're going to take the midterm and the final. There are a couple of software programs that that the department is using, and I'm trying to figure out what's going to work best for us. But anyway, so print out this test, just download it, open it up, and again, please do this on your own. It is extra credit, so you know you should do it on your own. But trying to open it up. See if it will open. There it is. Can you see that practice test? Is that popping up, or is it still just the Canvas page? It might not be popping up for you guys. But anyway, print it out and scan it and send it back to me as a document file, or if you do it with your phone, you can take a picture of each page and send me the JPEGs. Whatever works easiest for you. What works easiest for me would be if there's a way that you can scan it. If your printer at home has a scanner, or if you have access to a scanner and you can scan it all as one document and send it back to me that way, that would be easiest for me. But if that doesn't work for you, that's okay. Print it out, do the test, take a picture of each of the pages, send them back to me as JPEGs or a doc file or a PDF, whatever format you want to save it in. I will open it up in my iPad and I will grade it in, you know, with ink, and then I'll send it back to you. So this is just a practice to give us a feel for how our quizzes and tests are going to work. It is worth 10 points, and those 10 points will be added to your first test. Now you may not get all 10, you may get 7 or 8 or 6 or whatever, but those points will be added to your first test. All right? So are there any questions about how you're going to do this?
Is there going to be like a file we send it in, or do we email it to you?
Email it to me. Yep.
Okay.
Great question, Emily. Yes, email it to me. You can email it through Canvas, and that should be no problem. It is due by midnight tomorrow night. All right? So you've got 24, 25, about 26 hours to get it done. I would encourage you to do it first before you do your other homework stuff. And it's only over the stuff we've already talked about, plus there are a couple of problems from the video lecture that I uploaded on Friday last week. All right? Any other questions? Again, if you don't do this, that's okay. You just won't get the extra points. But this is how we're going to do our next test. And by the way, you're supposed to have a test a week from today. And as of right now, I'm still planning on doing it a week from today. All right. If, you know, given the fact we just lost 25 minutes of valuable class time, and, you know, if we don't get through all the content that we need to by the end of class on Thursday, I'll make a decision as to whether to push it back or not. But in general, this is going to be the format. So you're going to need access to a printer. Now, if you're on campus, and I know several of you are, I see Emily, it looks like she's hanging out maybe in Savannah or someplace like that. But anyway, you have access to printers on campus, and you should be able to print them out. All right. So that's the practice test. Any questions? Okay. The next thing I want to talk about is Kaltura, the media gallery over here. Again, all the videos are uploaded, but it takes a really long time to get these videos uploaded. I'm really surprised at how long it takes. So for example, this is the homework video. So if you have any questions over 6.4, the homework variation problems, watch this video. You can skip through it. I did every single problem because, you know, I wanted to make sure that if anybody had a question over a variety of things, that you would be able to see them. And then this is the lecture on section 6.6, which is graphing lines. So I encourage you again to watch these two videos. If you don't need any help with the homework, then you can just watch this one. Again, there are a couple of questions on your practice test from this lecture. One of them on finding slope and one of them on graphing a line. So I encourage you to do that. But what I wanted to say about Kaltura is it takes a really long time for some reason to get them uploaded. And so what I did initially, and maybe some of you, I know some of you actually did this because there were some views. I uploaded it to my YouTube channel and sent that link for those videos. And I know a few people actually went to YouTube and watched it, and that's fine. If necessary, I'll do that in the future. I'll immediately upload the video to YouTube because I can upload a video to YouTube in, you know, like 20 minutes. Whereas it seems like it takes Kaltura a couple hours. I don't know if it's because there's so many people uploading, although YouTube has a heck of a lot more people uploading videos, but it just seems to take too long to get it into Kaltura. So we'll see how that goes. All right, any questions about these videos? All right, I do try and describe them in the title so that you'll know exactly what you're looking at. Question? Did I hear something? No. I'm thinking right now out loud. Did anybody watch the homework video? Is there anybody who did? If you did, unmute and just say yes, I did.
Yeah,
Yes,
I
I
did.
did.
Yeah.
Great, great. Did you find that video clear and descriptive enough?
Yeah.
Yeah.
Yes.
Okay. Do you think that it would be better for me just to do the homework videos and upload them like that, and then we can spend the whole class time on the new stuff, or would you prefer to see the homework worked live?
I would say on YouTube would probably be like the easiest thing. So like you wouldn't be like caught up in everyone else talking type of thing.
Okay. Thank you, Emily. Any other input on that? I want, you know, in this new normal that we're trying to navigate through, I'm trying to figure out what works best for my students. And so I need your input. You know, I'm all about, you know, whatever works best for you. So anybody else have any thoughts on that?
You could like post all, like explaining all of them on a YouTube video, and then like certain like say 3 questions, if we all have them on Zoom, you could do those.
Okay. Okay. If I did that, I'd probably want to cut down the number of problems that I demonstrated live on Zoom, simply because the whole purpose of doing the video would be to save time during class for the lecture. But Emily, you make a good point. There might be like a couple word problems that you want a little more detail on. So I'm going to think on that. I don't know. I hadn't planned at the time. I don't know if I'll be able to do that for class on Thursday, but starting after the next test next week, maybe I will try and create the homework video. I've got to navigate things into my schedule. And again, like I said, and I'm only saying this because I want you guys to know I'm just a regular guy like you. I'm older than you are. I have more experience than you, but I'm just a regular person. You know, I've got responsibilities here at home. My wife's doing a lot better, but she's still on crutches, and I need to be able to help her and stuff like that. So I've got those things that I've got to navigate and fit into my schedule. So, and I do have 2 other online classes. They're not Zoom classes like this, but they are online classes that require a lot of detail. So I'm going to think on that. I appreciate your input. And like I said, I want to do what works best for you. So anyway, at the end of class, I hope I remember to do this. I don't want to do it now because if it screws it up and I get kicked out of Zoom, it would just tick us all off. But at the end of class, I'm going to try and hook my second monitor back up and see if we lose sound, if that's the issue. Because brought this second monitor home so that I would be able to be more productive and be able to see you guys while seeing the screen board at the same time, or the iPad at the same time. And so yeah, this is a little bit of a frustrating morning in terms of technology, but we're going to get it worked out. And I just appreciate so much all of your patience. All right. So what I want to do now is I'm going to stop this, and there you all are. It's like a giant Brady Bunch picture. We're going to go back to section 6.6. I'm going to demonstrate a couple of problems from the video lecture, a couple of problem types, but it's really important if you haven't watched the video lecture. And again, I'm not going to say who did and who didn't, because I'm not trying to call anybody out, but it's really important that you do watch the video lecture so that you can get deeper content and more problems. And then I'm going to go on to a little bit more of the new content. All right. So I think what I'll do is I'm going to work through a couple homework problems from the book, from section 6.6, and that will kind of show you what we're doing. So I'm going to be on page 337 in the book. By this point, you should all have your books. I'm not going to be pulling the e-text up anymore. We're in week 3, and if you don't have your book, you really need to get it. So I think what I'll do is I'm just going to pick a couple of random problems to demonstrate in the homework, and I'm going to share it on my iPad. If any of you watched the video, you know that I kept getting notifications popping up on my iPad. I have disabled notifications, so if anything pops up, then I'm going to be really, really ticked. But anyway, so let me get this. I'm going to share my screen. Excuse me. Here we go. Okay. So what I'm going to do is on page 337, I'm going to demonstrate problem number 45. Okay. And, oh, edit, that's right. I'm going to demonstrate problem number 45 first. Get this all set up. All right. Oh, come on. Okay. There we go. Problem number 45. And again, I don't know why it keeps flashing in and out like that. I'm really sorry about that. Problem number 45 says y equals 2x plus 1, and we want to graph this line. Now, a graph is just a picture of that equation, all right? And the way that we're going to graph this line is we're going to plot points. That's what the instructions say. So what you need to do to plot points is to create a table of values. We're going to create some ordered pairs or points. All right, I got to minimize that because there we go. And we're just going to pick some values for x, and then we're going to plug them into the equation. Now we want to get the equation solved for the letter y. This one is already solved for y, so that's very useful. And when it's solved for y, you can just pick some numbers at random. These are completely random, folks. I always like to pick 0 because it's easy to operate with. And then I like to pick a positive number, and I like to pick a negative number. And so I'm just going to pick those 3 numbers. All right. And then what we're going to do is we're going to plug these values in here for x.
Real quick, I know it's not a big deal, but I think it was 2x minus 1.
You are correct. Thank you, whoever said that. No, actually, if I'm going to demonstrate the problem, I should demonstrate it correctly. Thank you very much for catching that before I got any further into the problem. Great. I appreciate that, by the way. If I write a problem down wrong, call me out on it, because otherwise I'm doing something different and it's going to look different. So thank you. All right. So I'm going to put my, excuse me, I'm going to put my x values into the equation. So for the first one, it says 2 times x, 2 times 0. What's 2 times 0? Anybody? 0. Minus 1 would be negative 1.
Negative.
Exactly. Very good. And then 2 times 1 is 2. Minus 1 is 1. So there's another ordered pair. These are ordered pairs. You can think of them as being in parentheses if you'd like. And then 2 times -2 is -4 minus 1 is -5. So we're going to graph these 3 points. Now, hopefully you remember how to graph points, or you watched the video where I explained that. So from the origin, and the origin is the place where the x and the y-axis cross, we're going to move left or right first. Now 0 means we don't move left or right. We just stay right there, and then we drop down 1. So we have a point right there. That's the point 0, -1. Then 1, 1, from the origin, we would move 1 unit to the right and up a unit. And there's another point. And then -2, 5, we move 2 to the left because it's negative, and then we drop down 1, 2, 3, 4, 5 to right there. Those are our 3 points. And as you can see, those 3 points, I'm grabbing a ruler here. Those 3 points do form a line. If you don't put arrows on the end, I'm not going to count it wrong. But if you forget to graph the line, if you just draw the points and you don't connect the line, you will get it wrong. Also, you don't have to put in the little movements to the left and the right. You don't have to put those in if you don't want to. I put them in just to show you how I was moving on the graph. But that is the picture of the equation y equals 2x minus 1. All right. Does anybody have any questions about that? All right, look at number 49 for a minute. I'm not actually going to work out problem number 49, but what I want to do is I want to call your attention to it because it's a fraction. And if you watch the video, you'll know what I'm about to say, but when you have a fraction in front of your x, it can get a little messy because you'll end up with fractional answers, but you don't have to end up with fractional answers. If you pick numbers for x that are multiples of your denominator, then you will cancel out the fraction and you'll get nice integer solutions. So what I mean by that is, stop sharing this for a second, is that since the fraction is 1/2, if you pick multiples of 2, if you pick 2, 4, 6, 8, 10, or -2, -4, -6, -8, and so forth, that's going to cancel out that fraction and leave you with a nice number. So for example, the problem is y equals 1/2 x plus 4. If you let x equal 2, 1/2 times 2 is 1, plus 4 is 5. So you've got a nice integer solution. So even if it's fractions, you don't have to worry about getting fraction solutions. If you look at number 52, for example, it says y equals -2/3 x. So if you pick multiples of 3, like 3, 6, 9, and so forth, you'll get rid of the fraction and you'll be able to plot nice integer solutions. And the reason that that's helpful is because if you have nice integer solutions, it's easier. Let me go back and share this on the screen for a minute. It's much easier to graph those points. I'm going to have to do this every single time I go back to my iPad. So for example, integer solutions are where you, hang on a second here. Integer solutions are where the points cross, like right there, or right there, or right there. You can see they're right at nice intersections. If you have to graph a fraction, like if you have the ordered pair 1/2 -2/3, and you're trying to graph that, well, starting at the origin, you have to go over just a half, and then you go down a little more than half, and that's the point right there. It's a little harder to graph. So if you can get nice integer solutions for your graphs, it's going to make drawing lines a lot simpler. So that's an advantage to picking multiples of your denominator. All right, now get all this off of here. All right, the next one I want to look at is I want to look at problem number 65 on page 338. And in number 65, we're just finding the slope of a line. Now the slope is how steep a line is. And just as a reminder, if you watch the video, you know this already, but a line could go up like that, or it could go down. It could be horizontal, or it could be vertical. So those are the 4 types of lines, okay? Now, if a line is going up, like that one, the slope, and the slope is a number, by the way, the slope is positive. If a line is going down like that one, the slope is negative. If the slope, or if the line is horizontal, it has a 0 slope. And if it's vertical, it has no slope. So again, and I go through that in a little more detail in the video from last Thursday. So what we want to find right now is we want to find the slope of a line. This is number 65. The slope of a line that goes through the equation, or through the points, I'm sorry, 5, 1 and 8, 8. Now there's a formula that we use for this. And I'm going to show you the formula, but right now, before we do that, I'm going to graph those 2 points. This is not something that you would have to do in your homework, but I just want to show you where those 2 points are. 5, 1 is here, and 8, 8 is here. So let me ask you this question, and I'm going to try and connect these without grabbing my ruler. Okay. So let me ask you this question. The slope that we're going to find, is that going to be a positive number, a negative number, or 0, or no slope?
Positive.
Yes, it's going to be a positive number because the line is going up from left to right. Now let me remind you, there's a formula back on page, let me flip back here to the correct page. On page 333 in your book is the formula for the slope, okay? And that formula is M equals, now M is the letter that we always use for slope. M equals y2 minus y1 over, you know what, I'm going to move this down just a little bit. I need to be able to write underneath those 2 points. M equals y2 minus y1 over x2 minus x1. Okay, so the reason that we label these with x1, y1, and y1, y2 is because we've got 2 ordered pairs, and each of them has an x and a y. Now, it doesn't matter which one you designate your first point and your second point. I'm going to call this one my first point just because it's written first, and this one my second point because it's written second, but you could flip them. It doesn't matter, it would still work. So this is the x value of my first point and the y value of my first point. This is the x value of my second point and the y value of my second point. And now that we've identified those values, we can plug them into the formula very simply. Okay, and when we do that, y2 is 8 minus y1 is 1 over x2 is 8 minus x1 is 5. And when we simplify that, 8 minus 1 is 7 over 8 minus 5 is 3, and that is the slope of the line, 7/3. Leave it as an improper fraction. If it's an improper fraction, leave it that way. Don't turn it into a decimal, don't turn it into a mixed number. Because what the slope does is it identifies the change in the y values. The top number is your vertical change, and the bottom number is your horizontal change. So let me show you how that applies to the problem. The slope is 7/3. Let's go back up and look at the point right here. Okay, and I'm going to change to red. So if we're down here at this lower point and we want to get here to this upper point, we would need to go up 1, 2, 3, 4, 5, 6, 7 steps. That's a positive 7. And then we would travel to the right a positive 3. That is the vertical change over the horizontal change, which is the slope. That's how that comes about. And what's interesting about the slope is that we always do the vertical change first. We do the up, down first, and then the left, right. All right. So I'm going to show you one more problem in the homework. And again, these problems I'm showing you, nobody might have had questions about them. I hope that, I hope you tried some of these, but at the same time, for those of you who didn't watch the video yet, this is kind of showing you what it is that you'll be doing in the homework. Let's go ahead and look at problem number 75, okay? And problem number 75 says, let me get this up here. 75 says y equals negative 1/2 x plus 1. It asks us to graph this using the slope and the y-intercept. So it's important for you to understand the slope-intercept form of a line. That's a fancy name for saying that the line has been solved for the letter y. When we get an equation of a line solved for y, it's called slope-intercept form. And the number in front of the x is your slope. So in this problem, our slope is negative 1/2. That means that the line is going to go down from left to right. The letter B is our y-intercept. It's where the line crosses the y-axis. In fact, we're going to graph that first. We're going to graph that B first. So let's go ahead and do that. The B is a positive 1, so we're going to put a point on the y-axis at positive 1. Okay? Now, in order to draw a line, we need to find some other points. Well, remember that the slope is negative 1/2. Okay? That means that we're going to go down 1 step, and then we're going to go to the right 2 steps. So from the y-intercept, we're going to go down, and then we're going to go to the right. Down and to the right 2, down 1 and to the right 2. And you can see, and you don't have to do this many, I'm just doing it so that you can see that they all fall in a line. Now, I mentioned this to you before, but negative 1/2 is the same as 1 over negative 2. When you have a negative fraction, there's one negative sign, it's either top or bottom. So that means we could go up and to the left. And from the y-intercept, we could go up and to the left 2. Up 1 to the left 2, up 1 to the left 2. Again, you do not have to draw this many points. I'm simply showing you the pattern for the slope. And then of course you want to draw a straight line through that. I'm grabbing a ruler right here, and there it is. Put your arrowheads on there. Again, I won't count off if you don't draw the arrowheads. Now the question obviously is, well, Mr. Becker, you just drew like 8 or 9 points. How many do I have to draw? Technically, you only have to draw 2. You can put in your y-intercept and then find one other point. I would probably find at least, 3 points total minimum to make sure that you're counting it out correctly. But that's how you find the graph of a line using the slope and the y-intercept. All right. Are there any questions so far? Okay, so what I want to do now is we're going to move on to the second part of chapter 6.6, and what I'm going to do is I'm just going to kind of teach out of the exercises. I think that's the easiest way to go. Rather than show you a bunch of the examples, I want to focus on the exercises. So if you would turn in your books to page 338, I am going to pull up a new graph. Oops, that's an old graph. Let's see here, 12. Oh, that's an old graph. I need to go through and delete some of these, I think. There we go. All right, so here's what I want to do. The rest of this section, 6.6, is problems 79, 81, 83, 85, 87, 89. And then 99 and 101. So what I'm going to do is I'm going to do some of the even problems here. I'm going to demonstrate problem number 80 first, okay? So let's look at problem number 80, and this will help you understand how to do 79 and 81. So what we're doing here is we are finding the equation of the line given the graph. We're doing it backwards. We had been finding the line, drawing the line based on the equation. Now we're going to find the equation based on the line. So let me draw this out. So it goes through there, and it goes through there. Okay, so let me connect these with a ruler. Okay, so here's the line in problem number 80. In order to find the equation of the line, we want to write the equation y equals mx plus b, and we want to find out what m and b are. Okay. The first thing to find is the B. That's the easiest part. Remember, the B is the place where your line crosses the y-axis. So what is B in this problem? Anyone?
2.
Say it again.
2.
Yep, very good. B is 2 because that's where it crosses the y-axis. You can see right there. It's crossing the y-axis at 2. So B is 2. Good. Now, let me ask you this question. The slope of this line, is it going to be positive or negative?
Negative.
Are you sure?
It's positive.
It's going to be positive, right? Because the line is going up from left to right. So it's going to be a positive number. You don't have to put a positive sign, but I'm going to put a positive just to remind myself. Now, here's what you want to do. You want to put your pen or pencil on one of the points and you want to go to the other point. And I'm going to start with the point on the x-axis. So I'm going to start right here and I'm doing it in a different color. So remember that your vertical change, we're going to go up 1, up 2. Okay, that's a positive 2. That's your numerator. So we went up 2 and we got to here. Now we're going to go 1, 2, 3 points to the right. That's also a positive number. That's your denominator. So the slope of this line is 2/3. Okay? So when you rewrite the equation, it would be y equals 2/3 x plus 2. That's the equation of that line. And you found it by identifying the y-intercept and then identifying the slope. Okay? Any questions about that? All right, let's go ahead. By the way, I want to remind you that you can screenshot this stuff, or if you want, you can email me and ask me to send you a picture of, send you the file. I am doing this in Mac, on my Mac. Well, it's an iPad, so obviously. So it's in Pages, but Pages does translate into a doc file for Word, so whatever you prefer. But anyway, I can send it to you or you can screenshot it. Let's look at another problem. That's the one I just did. Okay, now let's look at number 82. Let me get this ready to go. I'll go back to black. And problem number 82. So this one goes through the y-axis here and has another point here. And I'm just going to draw a line through those with my ruler. Oops. There we go. Okay. So remember, we want to write it in the form y equals mx plus b. And so we need to identify m and b. And b is the easiest thing to identify. It's the y-intercept. So what is b here?
1.
1, thank you. Now, will this line have a negative or a positive slope?
Negative.
Yes, it is a negative slope because it is going down from left to right. And I'm going to change colors here. Remember that our vertical change is what we look at first. So I'm going to start at the left-hand point, which is the -1, 3. We're going to go down, oops, hang on a second here. We're going to go down 1, 2 points. So it's -2 over, and then we're just going to move over 1 point. So the slope is -2 over 1. So our equation is y equals -2 over 1 x plus 1. And of course, the question that some of you are thinking and somebody wants to ask is, do we have to put it over 1? And the answer is no. So you could write it this way. Both of these are fine. Okay, if you want to put that -2 over 1 because you want to think of the slope in terms of fractions, you can do that. If you just want it, since it's over 1, if you just want to write it as -2, you can do that as well. All right. Any questions on that one? Problem number 82. All right. We are going to go to problems 84 and 86, and we're going to do those on the same paper. Oops. Here we go. So edit I don't know why my notification popped up. I'm gonna have to check that into that. All right. So 84 and 86. Actually, hang on a second. I'll do them in different colors so that if you're screenshotting it, you'll know which one is which. So let's look at 84. Problem number 84 asks us to graph x equals -2. Okay. Now, we talked about this. I guess I talked about it in the video lecture. But when you have an equation x equals -2, what that means is that it doesn't matter what y equals, x will always be -2. So in other words, if you make a table of values, you can pick some values for y like 0, 1, and -2, but y is always going to be -2. So when we graph those points, like -2, 0, -2, 1, and -2, -2, you'll see that we get a vertical line. And in fact, anytime you graph an equation that just has the variable x in it, it doesn't have a y, it will always be a vertical line. Okay? And when we have a vertical line, oops, sorry. If you heard, I don't know if you heard that noise or not. That was my iPad resting on my computer. When you have a vertical line, it has no slope. Okay? Now number 86 asks us to graph. Hang on a second here. I'm going to kind of close this off so that we can keep them separated. Number 86 is y equals -4. And so just like when you have x by itself, the same thing happens when y equals -4. It doesn't matter what you pick for x, 0, 1, -2. Those are my go-to x values usually. But y is always going to be -4. So when you graph those points, there's 0, -4, there's 1, -4, there's -2, -4. And when you connect those points, you can see that they are, oh, hang on a second here, trying to get my ruler straight, horizontal. And whenever you have a horizontal line, the slope is 0. The slope is always 0 for a horizontal line. All right, so if you want to screenshot it, I zoomed out so you can see the whole page. And they're color coordinated. I think that's one of the things I really enjoy about my iPad. I actually got this iPad right at the, when we all had to go back in May or March, we all had to go online. I got it just for using with my students online. So anyway, all right. Any questions over 84 and 86? Anybody? All right, so what I want to do now is I want to look at problems 88 and 90, but I'm not going to draw anything out. I'm not going to draw them out. You should be able to look at them in your book. All right, and we're going to talk through how we know what the equations are. It's not terribly difficult. Let me end the screen share here for a minute. All right, so in problem number 88, you have a vertical line and it goes through 4 on the x-axis. Now, if you have a vertical line, the equation will be x equals, okay? Vertical line, we just looked at that in 84 and 86. In 84, we had x equals -2. It's a vertical line through -2. In this equation, or in this picture, we have a vertical line through a +4. So what would the equation be? Anybody?
X equals 4.
X equals 4. Very good. Thank you, Emily. That is correct. X equals 4. A vertical line will always be x equals whatever number it goes through. Okay? So then, by the same token, in problem number 90, we've got a horizontal line. So a horizontal line is going to be what kind of equation? What's that going to look like?
Y equals?
Exactly. It's going to be a y equals, and it's going through a +1, so the equation to that would naturally be y equals 1. All right. Now let me pause right there for a moment and see if anybody has any questions. Because we're going to go into the word problems now, and they're a little more complex. Are we good? Okay. So you're assigned problems 99 and 101. So I want to look at problem 100. I don't want to do the homework problems for you. I want to do similar ones. So let's look at problem number 100. Ryan sells chocolate on the internet. His monthly profit, P, in dollars, can be estimated by the equation P equals 15N minus 300. Now, I want to point something out to you here. This problem doesn't use X and Y, but it's still in slope-intercept form, okay? The X corresponds to the letter N, and the Y corresponds to the letter P. Now, if you wanted to, you could rewrite this as Y equals 15X minus 300, and then it would be, you know, formally in slope-intercept form, and you might feel more comfortable with it. But they're using letters that represent the problem, profit, and N is the number of dozens of chocolate. Remember, that's dozens of chocolates, okay? So if N equals 1, that's 1 dozen. And of course, we know a dozen is 12. So the first thing it asks us to do is to graph P equals 15N minus 300 when N is less than or equal to 60. So we're going to do that. I'm going to pull that up on my iPad and we're going to graph it. Now, in order to graph numbers this large on my iPad, we're going to have to scale it, okay? Because my graphs are only like, you know, in increments of 1. So I'm going to go ahead and open up a fresh document, and we're going to scale this. Let me go ahead and share my screen here, my iPad screen. Yeah. Screen mirroring. All right. So hopefully you guys can see that. So we're given the equation. Oh, let me get this into editing format. As a reminder, this is problem number 100. They give us the equation P equals 15N minus 300. Okay. Now, what I'm going to do is, I'm thinking about this for a minute, how I want to scale it, because I'm looking at the other numbers in the problem. If I let each value be 10, that would only go up as high as 100. But that should work. Okay. So what I'm going to do is think of each of these values as being in tens. So this is actually 20, 40, 60, 80, 100. Okay. So then obviously then this would be 10. First thing they ask us to do is graph P equals 15N minus, is minus 300 going to work? I'm not going to be able to get, well, it only goes down to minus 100. So what we're going to need to do is we're going to need to, instead of graphing this by finding the y-intercept, because the y-intercept will be off the graph, we're going to need to pick some values and graph a couple of them. And remember, we're graphing the ordered pairs NP. So let me see here. I'm going to let N equal 20, 30, not 30, hang on a second. I'm going to do N is 15, 20, and 25. Okay, and we're going to try graphing those. So, and again, if I had a bigger piece of graph paper, or if I scaled it differently, I would be able to use different values, but these are going to be the easiest. So when I let N equal 15, remember it's going to be 15 times 15 minus 300. So 15 times 15 is 225, minus 300 is a negative 75. Now, what that means, folks, is that if he sells 15 dozen chocolate boxes or whatever, he's going to lose $75 if he only sells 15. So in other words, he has to sell more in order to more than 15 in order to start making a profit. And this is normal in business. Anybody who goes into business, they're going to lose money initially until they start generating a profit that exceeds their sales. So 15 negative 75. Now, if we do the 20, it's 15 times 20 minus 300. And by the way, this is what we call the break-even point, because 15 times 20 is 300 minus 300 is 0. So that means that he has to sell 20 dozen chocolates just to break even. So once he sells his 21st dozen, he'll start making money. And then we'll do 25 times 20 is 500. 500 minus 300 is 200, which is actually off my graph. So it looks like we're just going to be able to graph those first 2 points. So 15 negative 75. Remember that each of these is in tens. So 15 is here. And then negative 75 is, we're going to go down 10, 20, 30, 40, 50, 60, 75, right there. Kind of in the middle. It's one of those fractional things that I told you I'd like to avoid if possible. So I'm going to take that out so that it's not confusing us. And then we're going to graph 20, 0. 20, 0 is right there. Wow, this is a very steep line. It's easy to see why it goes off the graph so quickly. So that's the line that we're asked to graph. Okay. Then it says, from the graph, estimate his profit if he sells 40 dozen in a month. Well, 40 dozen, that would be 40. And that's going to be so far off the charts that we can't even really graph it. So probably the easiest thing to do would be to go to the equation and put in the 40 and calculate it. By the way, I will tell you that if I give you a problem, a word problem similar to this, I will make it so that it fits on the graph. I will also provide graphs for you. I will provide the blank graphs for you on your quiz. If you've, has anybody opened up the practice test yet? And it's fine if you have. I'm not trying to catch anybody. So has anybody opened the practice test and looked at it yet?
Yes.
Okay, great.
Yeah.
Thank you, Christian. A couple people. Yep, Emily. So you'll notice that problem number 5 asks you to graph a line, and you'll notice I provided the graph for you.
Yes.
Yeah, great. So that's what I want you to understand, is that when I ask you to graph something, I will provide the graph for you. You will not need your own graph paper. You won't have to draw it by freehand or anything like that. So anyway, so 15 times 40 is 600 minus 300 equals 300. By the way, you know, it just occurred to me as I asked, and a couple people said they had opened it. You all might want to go to the announcements and try opening that, making sure that it'll open up on your computer before we finish this class, because if anybody has any problems getting it opened, you need to let me know so that we can figure out a different way. If I have to, I can email it to you individually, but hopefully that won't be necessary. Excuse me. My coffee's firing back at me. All right. Then let's see, what else does it say? We just estimated the profit if he sells 40 dozen. We didn't actually estimate it. We calculated it because the estimate would be off the graph. How many dozens of chocolates must he sell in a month to break even? Well, we figured that out, didn't we? We figured that out when we were, oh, that's a terrible, let me be a little more careful. When we found our ordered pairs to graph the line, we found that when he sells 20 dozen, he makes no money. But that's called the break-even point. Folks, the break-even point, I'm going to go a little bit into economics here. Many of you probably have to take an economics class. But the break-even point is a critical point for anybody in business to find. Nobody goes into business to break even. But you have to break even before you start making money, before you start making a profit. So initially, you're going to be making a loss, but hopefully your losses are decreasing over time, and eventually you hit what's called the break-even point. And that's a day to celebrate because, oh, we finally broke even in the business, which means that now we're going to start making a profit. So it's a very critical piece of information to find, is that break-even point. And in economics, we do something called break-even analysis. So anyway, does anybody have any questions over problem number 100?
Yeah, so when you have P equals 15 and minus 300, you put 25 times 20. Wouldn't it be 15 times 25?
Oh my gosh. Yeah, it sure would. I sure did. Which makes a lot of sense as to why it didn't want to work out. Thank you very much. Hang on a second. I made a mistake right here. Yep, that's embarrassing. Thank you for calling me on that. 15 times 25. And 15 times 25 is 375 minus 300 is 75. So thank you for catching that. So we can actually graph that. So there's 25 right there, and then we go up 1, 2, 3, 4, 5, 6, 7, and a little bit more to right there. Whoops. And I'm going to erase that out of there. So yes, there's that point in this line. Still had my eraser on. And it continues up like that. Well, that certainly explains why that point was so far off the graph. Thank you for catching that. So that third point would be 2575, which does appear on the graph. Yep, I got my numbers backwards. Who was that called me on that?
Me, Emily Soika.
Thank you, Emily. I appreciate you pointing that out. Again, I want to stress, don't be afraid to catch me in a mistake. And, you know, sometimes it feels good when we catch our professors in a mistake, but I'm not going to be one of these guys who, you know, oh, I was just seeing if you were paying attention. That's a bunch of BS. Any professor who tells you that? Anyway, I make mistakes. So thanks for catching that, Emily. I appreciate it. All right. So I think that gives us a good foundation for what we want to do in terms of the rest of your homework. I do want to, let me unshare this. My mouse is suddenly not working. My mouse is freezing. Where is it? Why is it doing that? Okay, can you still hear me?
Yes.
Okay, great. I'm glad that you can still hear me. My mouse is frozen for some reason. Sometimes that happens, so I'm going to wait a minute and see if it unfreezes. But what I want to do next is I want to go over to Canvas. I was going to go over to Canvas and come on, there we go. All right, cool. Okay, I want to share. My mouse is really being weird. I don't know what's going on here. It just keeps not wanting to move. I was going to go into the modules and just remind you of the homework. Okay, it's moving a little better. Come on. Here we go. All right, so right now we're at the beginning of week 3. So the week 3 agenda is problems 101, 103, and 105. Okay. I would also go back if you haven't done it yet. And I know there's probably some of you who didn't, you know, class was canceled on Thursday, and I'm human. I just like you. I know that you might not have gotten your homework. I would definitely go through these problems if you haven't done them already. Now my mouse is finally working. Okay. Oh, I spoke too soon. Anyway, so I definitely want you to make sure you get the homework done in 6.6. I would also encourage you to read ahead, if you are so inclined, to section 12.6, which is what we're going to talk about on Thursday. This is called linear regression. It's a statistics discussion, and it involves lines, finding equations of lines, which is why we group it here. Come on. I don't know what's going on with my mouse. All right. Couple things before we're done. Carly Eastman, do you have anything that you'd like to share regarding supplemental instruction?
So we have a session tomorrow from 4 to 5. We'll go over this graphing stuff, section 6.6. And then I'm trying to get an exam review session together from Monday. So as long as Jen says it's okay, which I'm sure she will, we're going to have an exam review Monday from 4 p.m. to 6 p.m.
Cool. Thank you very much, Carly. I do want to let you know, and this goes without saying, but I need to say it anyway. Like the practice test that I gave you guys, don't take it to SI and ask Carly to help you with the problems. That's not what she's for. She's not to help you with take-home tests and stuff like that. She's to help you with the concepts that we discussed in class. Is there anybody who did print out or did try and open the document and it gave you a problem? Not hearing anybody. Okay. I need a little bit of technical assistance here. A couple of things I want to try before I let you guys go. So my iPad normally allows me to share via cable, but it wasn't letting me share my screen via cable. So I'm going to try sharing it with the cable now. I've been doing it. It was all Bluetooth during class, which means I have to go through a process every time. So let me see real quick if I can share my iPad via cable. Okay, it's work. Can you guys see that graph that we just did?
Yeah.
Okay, so it wasn't working before. I don't understand why. All right, and then one more technical thing I want to try, and this is where I'm worried that something might go haywire, is I'm going to try plugging in my second monitor and seeing if you guys can still hear me, because I'm wondering if that wasn't the problem. So I'm going to plug in my second monitor, and then, okay, let's see here. If you suddenly can't hear me after I plug this in, give me a thumbs down, okay? Can you guys hear me? Michelle's nodding. You can still hear me?
Yeah.
Okay, so let me share this over here to this screen. And then I'm going to go back and share my iPad again. I'm just trying to make sure of the technical issues because your time is valuable. I don't want to, why is it doing, oh, I don't want to be wasting 25 minutes of your time in class. So let me see. Okay. But where did the rest of you go? Hang on a second here. Let me carry this over here like this. Go to that. Open it up wide. There we go. There you all are. And then go back to, okay. So can you still see the graph that I'm sharing on the screen?
Yes.
Yeah.
Okay, great. And I've got your pictures over here now. So the setup is working. Apparently I just needed to restart my computer for some reason. I'm going to log in on Thursday a lot earlier. Probably 9:30 so that I can make sure that this doesn't happen. Again, I apologize. Again, I'm looking at you guys now. When I'm looking over here and you're like, he's not paying attention to us, I'm actually looking at your faces. But anyway, real quick, one last thing before I let you go. I tried to get attendance. There's some people I missed. Is Bailey Arnold here? Unmute yourself and say here if you're here. Bailey? Gabriella, I see you. Yep, you're here. Barbara Carbajal.
Here.
Thank you, Barbara. Jessica Castillo.
Here.
Thank you. Jocelyn Cisneros.
Here.
Thank you, Jocelyn. Diamond Irvin. Diamond? No? Daniel Zielinski. Oh, I see you, Daniel. I see you. Lauren LeGrand. Lauren? All right, I got everybody else. You guys, I want to thank you again for your patience. It's always a little frustrating when things like this happen, and probably frustrating for you. Couldn't have been more frustrating than it was for me. I got to tell you, I was just really tearing my hair out. So anyway, I am going to save this video and I will get it posted so that anybody who missed it can go back and look at it. Again, I want to remind you that the deadline for this take-home practice test is tomorrow night. If you have any questions, any issues with getting it to me, contact me and let me know. Communication is key, folks. I am very understanding when you contact me and say, hey, Mr. Becker, I had to work and I couldn't get it done. Can I get a little extra time? If that happens once in a while, I'm very understanding about that. If it happens every time, then we have an issue that we need to work through in terms of time management. But in general, I'm a very understanding guy. I want you to succeed, and so I'm willing to give you that latitude as long as you don't take advantage of it. But if you're having any problems printing it out, if you have any questions, feel free to ask, all right? Please, please, please don't go to YouTube and try and find solutions to these problems. Work them out on your own, because you're going to be monitored when you take your midterm and your final. I don't know what the software program looks like that's going to monitor you for that. There are 2 that we're looking at, but you're going to be monitored and you're going to have to perform that stuff. So if you can perform it while you're, doing practice tests and stuff like that, great. By the way, I don't want to forget this. Open book, open notes. You can use your book. You can use your notes to solve these problems. That's not cheating. All of your quizzes and tests, other than the midterm and the final, are open book and open notes. So feel free to do that. It's just not, open up your instant messenger and talk to your friends. That's the only thing you can't do. So are there any other questions?
Mr. Becker,
Yes.
You can go.
sorry. We can't see module week 3.
You can't see it? Oh, it's not open yet?
No.
No,
Oh, hang
that
on a
was my
sec.
question too.
Me too.
I'm sorry. Well, you know why? Because your idiot instructor didn't publish it. It's open now. I'm so sorry.
Thank you.
No problem. In fact, just so that I don't forget, I'm going to open up the week 4 agenda as well. I guess I could open all these up because you guys are likely not to try and work ahead. It doesn't make sense to. In my online classes where they're working kind of at their own, not at their own pace, but I had somebody try and do like, they were working out through week 5 and they're just getting too far ahead of themselves. So I had to do that. But can somebody check? Can you access
Yeah.
it? Great.
Yes.
Great. It was the click of a button. Very sorry. Glad you asked that question. And that was the same question somebody else had?
Yeah.
Okay, cool. Anything else? No? All right. Then I am going to go ahead and let you guys go. I will see you on Thursday. And again, I'm going to log in early on Thursday to hopefully work through any of these technical issues that I might have. Once again, thank you so much for your patience. I deeply, deeply appreciate it. You guys have a great day.
You too.
Yes, sir.
Bye.
Easy with you.